Problem. Two lighthouses, 1,200 meters apart on a shore that runs west to east, are at the points F1, x negative 600 and y at 0, and F2 with x at 600 and y at 0, as shown in the figure below. Both lighthouses at the same moment send a message to a ship at sea. The ship received messages from F2 at 3.5 seconds before it received the message from F1. Assume that the messages sent as radio signals traveled as a constant speed of 3 times 10 raised to negative 4 meter over microsecond.
The following are the given for the problem above. Speed ratio, 3 times 10 raised to negative 4 meters per microsecond. Time difference is 3.5 seconds. The center is 0, 0. What is asked for the problem is, if A is equals to B, we need to find A. To find A, we need to find for the transverse axis. The formula for the transverse axis is x minus 8 raised to 2 over A squared minus y minus k squared over B squared equals to 1. D equals Vt or D equals V times T1 minus T2. F1 to P minus F2 to P equals constant. Constant equals the transverse axis.
The situation will look like this in the graph.
So before we start, we will let F1 to P be D1 and let F2 to P be D2. Since D1 is delayed for 3.5 seconds, we will set D1 to X plus 3.5 seconds and then D2 we will set it to X. Since D1 has a unit of time, we will set this to T1. So T1 is X plus 3.5 seconds while T2 is equal to X. To get the constant, we can rewrite the distance equation into C is equal to the speed ratio multiplied to the difference of T1 and T2. After substituting, constant is equal to 3 times 10 raised to negative 4 meter per microsecond multiplied to x plus 3.5 seconds minus x. Since T1 is minus T2, so x will be removed, leaving 3 times 10 raised to negative 4 meter per microsecond multiplied to 3.5 seconds. Since the speed ratio has the unit of microsecond, we will convert the time into microsecond. 3.5 seconds multiplied to 1 million microseconds over 1 seconds will leave you 3.5 million microseconds. After getting the answer, we will now substitute it again, leaving you 3 times 10 raised to negative 4 meter per microseconds multiplied to 3.5 million microseconds, and it will yield to an answer of 1050 meter, which is equal to your constant, or in other words, your transverse axis.
To find the equation of A is equal to transverse axis over 2. Our transverse axis is 1050 meter. That's why 1050 meter over 2. Our A is equal to 525 meter. Since A is equal to B, B is also 525 meter. The standard form will be x squared is equal to 525 meter quantity squared minus y squared over 525 meter quantity squared is equal to 1.
To convert standard form to general equation, we need to multiply all sides by 525 meter quantity squared, and it will result to x squared minus y squared equals to 525 meter quantity squared. It is also equals to 275,625 meters squared. In conclusion, we can write its general form x squared minus y squared minus 275,625 meters squared equals to 0.
For letter B, if the ship is directly the north of F2, how far is it from the shore? We will use the general equation x squared minus y squared minus 275,625 meters squared equals 0. We will substitute this into x. This will then be 600 meters squared minus y squared minus 27 minus 275,625 meters squared equals 0. We can rewrite the equation into y squared equals to 360,000 meters squared minus 275,625 meters squared. This is y squared. We will get its square root and this will be our answer. Y is equals to 290.47 meters.
The graph will look like this at problem B.
C. If the ship is 400 meters away from the shore, what is the coordinate? So the given is y equals 400 meters and x is unknown. To solve x, we need to use the general formula. X squared minus y squared minus 275,625 meters squared equals to 0. Next, substitute 400 meters to y squared. You will came up to 400 meters squared minus 275,625 meters squared. Next, 160,000 m squared plus 275,625 meters squared. And it is transposed, so they have a plus sign. Since x squared is squared, we can square the both terms and we'll have an answer. X is equal to 660.2 meters and it is the coordinate.
The graph will look like this at problem C.
A. Find the equation of the hyperbola comprising the possible locations of the ship. In A, x squared minus y squared minus 275,625 meters squared equals to 0. B. If the ship is directly north of F2, how far is it from the shore? In B, 600 meter, 290.47 meter. C. If the ship is 400 meter away from the shore, what are its coordinates? In C, 660.02 meter, 400 meters.